Thanks. Sorry about that, everybody. Didn't.
Okay. For the recording, my name is Kenny. This is my wife, Asha, and we're presenting 5G capabilities in comparison with 4G. So as I said, 4G has upload, download capability on the current system, but 5G is only download. It requires an existing 4G system in order to connect to the 5G antenna system and to download from it. So our 4G systems have a max download speed of about 300 to 400 megabits per second on a good day when the sun is shining, there's no clouds in the sky, and the stars are aligning for you. With 5G, we have personally tested and tested up to 3 gigabits per second download speed. The average is closer to 1 to 1.2 gigabits per second. But again, if you, I'll kind of go into it a little bit later. If you do certain things, you can hit that 3 gigabits per second. On the upload side, 4G kind of, it starts about 20 megabits per second and it will max out about 120 megabits per second. But the 5G, no upload speed. So when you have a 5G phone and it will show that you're on a 5G network, your upload is only on the 4G system, not on the 5G system. And 4G now works by aggregation of multiple bands, the low band, the high band, and the C band, or the CBRS system. And for the most part, CBRS is not generally used or found by your phone, so to speak. Your phone knows it's there via a software connection with a tower or a DAS system, but your phone will not connect to a CBRS system to make a phone call unless you have an actual CBRS-based phone. But the carriers will use the CBRS band to download simultaneously data to your phone along with the low and high band downloads. And that's how they can reach now 300 to 400 megabits per second. With the 5G, we have a single source, meaning a single antenna going to a backhaul system, and fiber is required from the 5G antenna to the head end system or the backhaul system in order to reach the 5G speeds. When an antenna is broadcasting our 4G with the low band and high band, we can design the system to take into account reflections off of metal structures, a little bit of bending, so to speak, as well as wall penetration. But in the 5G capabilities, if you can see Goku on the screen there, what we found was you need direct line of sight in order to use it. So when we were testing, we would quite literally take our phones and hold them like Goku does in the comics, in the manga, and run the test with the back of the phone, the antenna, pointing directly to the antenna on your phone, pointing directly to the antenna that's broadcasting the 5G signal. That is one of the only ways that you can get greater than 1 gigabyte per second of speed. When the phone is pointing away from the antenna, the direct source, if you say have the front of the phone facing it, you'll lose maybe 250 megabits per second. The phone will block that much signal. If you have your body between your phone and the antenna, you can lose upwards of 1 gigabit per second. Your body really puts in that much interference and signal absorption. And so while you can have a grand speed, if you don't have direct line of sight between your phone and the antenna, you really won't get what the carriers advertise. And there's almost no wall penetration. We would get surprised occasionally to see how the signal go through a concrete floor or a concrete wall, but generally speaking, you lose all connection. Your phone may say you're on a 5G system, but you're only going to get 4G download speed. And what's also somewhat a misnomer that's coming out with 5G is our 4G system operates on low band, which is 700 and 850, high band, which is 1.9, 2.1, 2.3, and 2.5 megahertz. but 5G operates on all of those, as well as the millimeter wavelength, which is 28 and 39 gigahertz. So we can do, or the carriers are enabling and operating 5G systems without actually having millimeter wavelength technology. And much of that has to do with fiber optic connections and aggregating all of the low and the high band signals together to data burst, so to speak, to data burst packages of data, and then your phone combines it all together to make it appear faster. So to get now into kind of the technology, how do these systems work? How are they set up? Again, the comparison, we have 4G starting at the backhaul side, which is the carrier integration system integrating with a tower or with a DAS system. DAS is being at venues. We will have standard coax internet service providers, fiber-based ISPs, and occasionally there'll be a donor antenna that will rebroadcast to a nearby tower. And so in the 4G world, these all work, and you can still get generally good speeds for upload and download, but they are slower. For the 5G carrier integration at the backhaul, the ultra wideband, that's the one that's getting advertised that everyone thinks about with 5G. That's the millimeter wavelength. You must have a complete fiber system from the 5G antenna all the way to the carrier server. So a fiber from antenna to the head end DAS support system, from there to the carrier backhaul, from the carrier backhaul to the internet service provider, the local guys and their fiber all the way into the internet servers, and then from there to the carrier servers. That is pretty much the only way you can get above about 1 gigabit, maybe 1.5 gigabit per second. Most 5G phones will end up operating on the wideband, or what some carriers will refer to as the nationwide wideband, and that's the use of high-speed ISPs. So there's fiber along the way, but somewhere there's probably just going to be your basic coax style connection or an Ethernet style connection that can still be high speed, 300, 400, 500 megabits per second, but it will slow down the whole process. But you'll still end up with a higher speed than the 4G system. And then there's the general 5G, which can be high-speed ISPs or a rebroadcasting via a donor antenna from one point to another. If you can get fiber, so to speak, as long as there's some fiber in there somewhere, it can go pretty quickly. Then from the head end system, or the base of the tower, so to speak, going up to the antenna or out to the DAS system, we have seen personally in what we have worked on, repaired, we've seen fiber mixed with a local power source, meaning your node, your antenna system at a venue or the tower has a local power source. You just plugged into something nearby. We've seen fiber mixed with volt server. We've seen Ethernet with a local power source, and we've seen direct coax connections from the head end right out to the antenna. For direct coax, we usually only see like a system with 1 to 4 maybe antenna, and they're all nearby, so small buildings, localized necessities. But with 5G, it is completely 100% right now fiber combined with volt server. So the volt server is providing power and intermittent power along with communication to a node, and then the fiber is connecting to the 5G antenna. So the antenna receives power and communicates with the DAS system to basically say, I'm here, I have no problems. And the fiber is connecting your data stream between the transmission from the actual individual antenna within the antenna to the backhaul system. Antenna types, again, we're using 4G. We have been to places that had a metal plate screwed up on a wall, and they just connected a wire to the metal plate, and that was the transmission source. And we've seen that in malls. That blew my mind when I first saw that. I thought to myself, surely we have come farther in technology than this. But apparently we still have not. There are still some venues that are out using 15-year-old technology, and your phone, brand new S21's iPhone 13 is still connecting to the system via 15-year-old technology. But the main thing I want to take away from the antenna type when it comes to 4G is that you can hide a 4G antenna. It can be behind a wall. It can be in a back service corridor. It can be up on a building, and you can have no direct line of sight, and your 4G system will still work. But with a 5G system, the antenna must be visible to you in order for it to be usable by you. The antennas themselves will look like a single panel antenna, but it actually has 64 internal, or up to 64 internal antenna, each one transmitting at a different angle in order to cover a larger area. And each antenna will only connect to the cell phones that are within that range, within that angle range, basically. So a single antenna, to help divide down or increase the capable traffic load, it's divided into these 64 antenna. Now, connecting with a 4G system, your phone can see a 4G system down to neg 120 RSRP, the power level there. If your SINAR is good enough, you can make a phone call at neg 120. So I think generally SINAR above 20, you'll be able to make a phone call at neg 120 RSRP. You won't send a text message. You won't be able to get on social media or do any kind of data type connection, but your phone will still see it and you can still receive a signal. But generally around neg 105, in your average everyday out and about, you're going to lose all connection with your phone. You'll have difficulty making a phone call. You won't send a text message, no data connection whatsoever. So that's kind of the limitation of 4G. On the 5G system, it requires a minimum of neg 105 RSRP on the pilot signal in order to connect. And most of your 5G antennas, their max output power at the antenna is going to be around neg 60 dB. Sometimes a little higher for larger area systems, ones that need to project farther. But 5G range is very limited, maybe at best about 500 yards, really, I think is what we're seeing in practicality. So that's why they're setting up 5G all over the place. But once your phone is connected at neg 105 or better, if you walk away from the source and that RSRP goes down, you can go down to neg 120 on the pilot signal and still get a 5G connection and still get a 5G download speed. So it just requires neg 105 to connect, but you can still go down lower than that. So if you kind of round a corner or something, or you're driving and you're getting a little farther away from the source, you'll still be connected even down to neg 120, because 4G, and I don't think I put this in one of the slides, 4G is always on. 5G is on when in use, but it has a pilot signal that is always on. So your phone connects to the pilot signal, not to a millimeter wavelength constant on signal. Oh, and this is a PCTEL 5G scanner. On the right, you'll see the top side of the HB Flex scanner. This is what we used at the 2 Super Bowls.
Kenny, we're not seeing the slides. We're just seeing the.
You're not seeing the slides.
They're not advancing. We're still on the first slide.
Oh.
You sharing the wrong.
I'm gonna stop sharing, and I don't know. Maybe maybe when it went to recording, it did something weird.
Try sharing again.
Let's try sharing it again.
You may have 2 screens, 2 monitors, and you're sharing the wrong one, because we're just seeing your presentation, the PowerPoint, but not the presentation.
All right.
There we go. We see slide number 6 now.
You're seeing slide number 6.
Right, we didn't see, originally we were just seeing slide 1. Now we're up to 6. So we are seeing, we are now seeing you advance.
But it's
Well,
not full screen, it's just the application we're seeing.
Yeah, we're still seeing the PowerPoint window.
Okay, I don't understand that.
Well, we could just
Let's see.
probably just.
Yeah, let me,
Yeah.
all right.
Yeah, if you click them on the side there.
Just hit F5 and it'll go full screen.
All right. Are you back to seeing the first slide?
Now, we're still
No.
seeing slide
Yeah.
5. So I
Doing
think
something
you're-
weird on.
You're probably in presentation mode. And we're seeing,
Yeah. Let's see. It says we're sharing. So you're
so
seeing.
yeah, if you just click down the side of that screen there where your cursor is.
All right. Are you seeing? So
Yeah, if
are
you're
you
describing the
screen-
pictures there? There we go.
Yeah, we're good. Now we see it now. Looks good.
Yeah, just
There,
advance
Ken.
it that way.
All the previous slides, so they will have that in the recording.
Yeah. All right. So I'll start back up here. Not on this one. I'll start on this one. Then it's in the recording. Just some general data. This is what I was going through. So we have Goku with his Kamehameha. All right, so I'm going to run through some pictures. If I can, why is this not? I need the hide button. Oh, that's fine. So this here is our HB Flex PCTEL HB Flex scanner. This is used for scanning the 5G system. It will not scan 4G. It will only scan 5G. And this is what we've been using. This is the top of the line right now that we know of, top of the line. And we've seen quite a few other carriers using this one as well. We do enjoy walking it around with it. People tell us we look like space aliens.
Oh, the
this
millimeter
is-
puck, the antenna looks different, so.
Oh, so
Oh, why don't we use it? Why don't you use a Star Trek reference? You look like Captain Picard or something.
yes, I look like, well, do I look like Picard or Geordi?
Yeah, that's true.
I'm going for Geordi, I guess in this. I'm going for Geordi. So this is the 5G receiver antenna. And there's 2 of them on these telescoping poles. Your phone antenna will look a little differently, and I think we'll see something in 2 slides that'll see more like what your phone antenna will actually look like. But this will pick up at a greater distance than your phone. Here is a 5G, and that's hard to see with it small, but there is a 5G antenna at a stadium. Yeah, there we go. This happens to be the Hard Rock Stadium. This particular antenna is currently being decommissioned. And so I feel comfortable sharing this. I tried to get permission from Verizon to share actual data that we collected, but they would not give us permission to share that data as 5G is still considered to be very new for the carriers, and they don't want the information out and about yet. Especially because all of these carriers keep saying the same thing about themselves, and we just end up chuckling.
You guys get into any of the debates of the controversy as well?
Especially
if it's near an airport, from what I understand.
Yeah, we talk about it ourselves, but we have not gotten into any strong debates with anyone. I'm not so convinced about the 5G issues that they're claiming with planes, interference with planes.
Yeah, what I find interesting is United States is not the first to do this, right? I mean, which is unusual. I mean, if there'd been issues, you would have thought other countries or wherever would have had these problems.
Exactly. South Korea tends to be the testing ground for this new cell phone technology. They've had 5G, both upload and download 5G capabilities for several years now. And
they're at least 2 years ahead.
Yeah, they're generally 2 years ahead of us. So we don't, then again, that's part of why we're not so convinced. I think it often just comes down to NIMBY, not in my backyard. People are seeing these towers going up all over the place. We've had more discussions about that. What is this new tower that I'm seeing in my neighborhood? And what is it going to do to me? Than we have anything else really when it's come to 5G. So we've constantly reminded people it's not going to kill you. It's just the advancement of technology, and you're going to see these all over the place. Carriers are doing what they can to make them as inconspicuous as they can, but fear will always be there. So, but like most things, this isn't gonna kill you. Like 4G, it's not gonna kill you. My only personal issue is that if you're receiving into your body the millimeter wavelength, it is not going through you. And a waveform is an electron, it's a form of a wave. So if the electron is not passing through you and hitting something else, then that means it's entering you and staying in you. So that's going to create free radicals in your body. That's kind of the worst that's going to happen to you. 4G more readily passes through you because they're lower bands, lower frequency waves, so they'll pass through you better. But the millimeter wave kind of hits you and stops. And that's the biggest concern that I have. But the nice thing is on the 5G, it's only active when it's in use. So if it's not outputting a signal to a phone, then you're not getting bombarded with it like you are with 4G, which is constantly on. And we can attest that in working in the stadiums on the 4G systems, after 10 hours a day, we could end up with headaches by the end because we're heavily bombarded constantly because the system's on and running at full capacity during testing. So we can say we get a little bit too much energy at times, and we end up a little dehydrated and get headaches. But for the most part,
4G.
And that's with the 4G system. But we've not faced anything with the 5G system like that. And on the screen now, if you can see it, is the Ericsson 5G antenna. This is what Verizon has been using, what we've been testing. And on the right-hand side, you can see each one of these little panels is an antenna. So there are 64 individual antenna in this picture, comprising one large antenna. And that's how they get a roughly 120-degree wide beam angle on a horizontal plane. And so these are popping up. So again, you have to be facing this front panel in order to get the millimeter wavelength. It does not have a back lobe the same way that a 4G system has a back lobe. So if you're standing behind a 4G directional antenna, you can still connect if you're right behind it because the signal shoots out the back as well. But with this, the signal is pretty exclusively forward facing. So you do have to be in front of a 5G antenna for it to operate correctly.
How much
And
ERP?
I'm sorry, say again?
How much ERP?
That I'm honestly not certain about. We spoke with that. We actually spoke with the tester for that when he came to the stadiums to test, but he never showed us the results for the 5G. Oh, actually, I don't think we can. We couldn't really get a result for the 5G because all the 5G antenna were up in the rafters.
If you run the Frias equation backward from your device, you could get a ballpark on the ERPs.
Might have to try that sometime.
Pull one of your data plots and you can run it.
Okay. We'll have to do that. We'll have to see.
Is there some limit to the amount of power going into the antenna? Is it like the other stuff, typically like a half a watt or something like that?
These, I believe, are 5 watt is what was being used at the stadiums. You can adjust the wattage depending on the range it needs to cover. I believe the units that you'll find out on the ground in neighborhoods, I believe those are operating at about half a watt. But to get the range that you need for a stadium, I believe they were hitting up at 5 watts.
And that's before the antenna gain.
Yes.
Wow.
Does the amplifier
I'm sorry, all I heard was amplifier. The 5G antenna, let me go back up to it. Oh, there we go. Your amplifier will be within the unit itself. So for these 5G systems, that's what part of the comparison I wanted to make. On the right-hand side of this screen, you'll see a 4G node along with a combiner before it goes out to the antenna. So there's the connection from the head end will go here, and then it will go out to your different antenna. Whereas with your 5G system, you've got a direct fiber connection and power connection to this unit, and it stands alone by itself. So this is a 4G antenna at Hard Rock Stadium, and that is under the seat. So just for comparison, the 4G systems will be very close, whereas the 5G systems will be up overhead. They would not be able to use a 5G system underneath people. So there's the overhead again. All right, now when we are out testing and reviewing the data, this is what I can show effectively. We have the RSRP for the 4G. We'll zoom in. This is a heat map requested specifically by CommScope for use for their analysis. So this on the 4G side breaks down every 3 dB to give them a better sense of how much power and the range and what the design, if the design is truly working. And you'll see that the vast majority of power that we're seeing is going to be between roughly -80 and -65 or so. And the closer we are to the antenna, the higher the power, of course. Whereas in comparison on the 5G SSBRP plot, we're recording out, we're producing out to -45, but you could see like above -85, we're not really getting anything. When you're that far away from the antenna, it's hard to get a signal. But the most signal we had, and this was pre-optimization. This particular data source, I think, came from a walk of the first level of the bowl. We were mostly just barely able, because if you recall me saying you have to hit neg 105 or better in order to actually connect to the 5G system. So at this point in time, most places that we walked would not actually would not actually connect to the 5G system. It would be outside that range. So pre-optimization. And then the next primary comparison will be our SINAR, which is our, well, you guys know what that is. So SINAR. So again, in our optimization and our pre-optimization state, we're seeing not so good numbers, but it's the beginning. So we're working towards, well, it was the beginning of the project. So we were working towards the improvements. But even still, SINAR, and again on the SSB, it's just a pilot signal. So interference is not necessarily an issue for that, as data is not being transferred along it, other than for the antenna to notify your phone that it exists. So so SINAR, while we were looking at it, while we were reviewing it and taking it into consideration, was not a primary concern. The SSBRP was our primary concern, and I really do wish I could have shown the plot from the RSRP as the system looks dead. Even when it was optimized, the system still looked dead in comparison to a 4G system. But because it's a pilot signal, you don't need a lot of power. You just need the phone to pick it up and recognize it, and then it uses the 4G, the nearby 4G node as its anchor point, so that the 5G node, 5G antenna knows which individual antenna to use as the transmission source. And here I have created just a visual for the explanation. Zoom down, scroll down just a little. Yep, that's not working. There we go. It should show it. So some of our testing, this is my visualization of a suite at a stadium. This will be the roof of the suite, and then this will be a suite you can walk out and stand within the stadium. Generally speaking, once you got outside of a suite, you'd have about neg 90 dB on the pilot signal. And once you stepped underneath that overhang, you drop down to about neg 105. So for someone in practicality, being at a stadium or in anywhere really, you had to step out, get a line of sight on your 5G antenna before you could walk backwards, and you'd still have 5G download capability at the back door, even though you had no direct line of sight on the 5G antenna. So we often found ourselves in situations for testing and verification where that was exactly what we had to do first in order to test the system. We had to walk out to see the antenna, make sure the phone connected, then walk backwards to do actual testing at the back of a back service hallways or back of a suite or in out of the way places. And that is kind of one of the limitations that we have found with 5G, even to the point that carriers for their suites at a stadium, they will install a 5G system in that suite so that it looks to the executives like they've got excellent signal and excellent 5G coverage. But they have to add an actual 5G antenna in order to have that kind of coverage that you would find out in the seats. So kind of again, as that recap, when we were be on the top level, closest to the 5G antenna, here we go. When we would get up onto the third level of stadium seating closest to it, and we pointed the back of the phone right at a 5G antenna, that's when we could get 3 gigabits per second. When we got down to the first level, we were hitting maybe 800 to 900 megabits per second. Still better than 4G download speeds, but not necessarily what would be advertised.
So, okay, Ken, quick question. Sorry to
Yes, sir.
interrupt.
Oh, no worries.
So are these really line of sight devices?
Yes.
Okay.
It really, truly is. In fact, I'm actually done. So we're at Q&A, and for your viewing pleasures, if you can see Bernie Sanders there in his mitts. At the Raymond James Stadium last year, with COVID in full swing, they were selling basically cardboard cutouts. People could buy a cardboard cutout and have it put in a seat to represent themselves. And a lot of people bought Bernie Sanders from the inauguration day, sitting in his lawn chair with his mitts. So the fun things we run into sometimes in these stadiums. But yes, line of sight, and that kind of surprised us the most because we're accustomed to the 4G system where you do not need line of sight. You do not need to even see an antenna in order to test it. But with the 5G phone, the antenna is on the back panel, and even that panel of the phone, the panel that has to be there, will block and lower the quality of the signal. And then if you put a case on top of that, the case blocks it even more. So for a 5G antenna or for a 5G phone, we would not recommend putting a case that has a back panel on it. You would need something that's got a hole cut out. And I think they've started selling those now, cases for 5G phones that have a hole at the back of the case so that the 5G antenna itself has no obstructions.
And Samsung took some extensive notes, and they are probably going to develop a phone that has the 5G antenna on the phone, on top of the phone, rather than on the back of the phone. But I don't think that is
Come out.
No, that's not
Probably
coming
hasn't come out
for-
yet. Yeah, that may come out when we get upload capability.
So you're saying if they put a 5G antenna down the street from my house, half a block away, that it's not going to help me any unless I'm outside mowing my lawn.
basically.
Or you'll need to go into your front porch or your balcony and aim your phone at the 5G antenna. Make sure your phone connects to the 5G antenna, and then you can proceed on forward into your house, and then
You'll be connected, but in all truth, you'll still end up with mostly 4G download speeds.
And when the phone says, like right now, my phone says 5GE, what is that?
The E is for nationwide, the nationwide coverage. Do you have Verizon?
No, it's AT&T.
AT&T, yeah, AT&T, yeah, I think Verizon uses N. Yeah, that's the generic coverage. So basically right now you are effectively operating on the 4G system. You are probably connected to a 4G node that has fiber connections.
Correct.
So that it has the higher speeds. But yeah, if you did a speed test on your phone right now, you might hit 500 megabits per second.
I did it a few times, and I'm only getting about 150 down and about 20 up.
So you're definitely on the 4G system. Yeah. One of those things told to us while we were doing testing, because we came back, hey, this phone got 300 megabits per second on the test, and they would just kind of spin around to us because we thought, okay, that's pretty good, 300 megabits per second. They said, no, you're on the 4G system. I said, but the phone says we're on 5G. They said it doesn't matter. The phone, effectively speaking, the phone is lying to you. But you didn't hear me say that about the carriers whom we love, who pay our bills.
Well, we knew that.
Yeah.
Well, you know, the one thing, Mike, you're not cheating, but we do have the AT&T DAS in the building here.
Yeah, that's what I was going to say. We have a DAS in the building hooked to fiber, but we also have a 5G antenna right behind our building, probably 200 yards away. So I'm wondering, if my phone connecting to it, seeing that, but yet using a 4G outbound,
Yes.
kind of what's it? Okay.
Yes, when you were outside the building, if you drove by it or walked in a direct line of sight to it, your phone connected to that, and it anchored to the 4G system of your it connected to the 4G system of the DAS, and so your phone thinks it's on 5G because you probably have a better than neg 120 RSRP connection, but you're not actually getting 5G capability.
Okay.
But it's that way. It's effectively that way in order to convince the masses or to make the masses feel good. The phones have the same thing with the 5 bars of, you can think, oh, I have 5 bars. I should be able to make a phone call, send a text message, look at social media, and then your phone doesn't seem to work right. And you think it's a problem with the carrier, but those 5 bars actually don't mean anything. They're mainly just there to make you feel like you have connection to something. So we were finding that the 5G system was kind of operating the same way. We could, the test phones we have would say 5G, but they wouldn't get 5G download speeds. And so really, as we would think about what the practical application was for a 5G system, we found ourselves thinking that it was more say you're about to get on a plane or a train or go on a long ride or something somewhere, and you want to have a movie or an audiobook or something, and you just realize, oh, I haven't downloaded anything to my phone. You can very quickly point your phone at a 5G antenna, and within seconds, you can download an entire movie. At 3 gigabytes per second, you can download the entire extended edition of Lord of the Rings trilogy in like 2.5 seconds.
So this is their version of like our local cable provider putting Wi-Fi around everywhere. You have to physically connect to Wi-Fi to know it's there and have an account. With the cell version of it, 5G, it's all transparent. It just happens in the background, but it's in effect the same workflow for the user. Okay.
Basically.
That's
Yep. And speaking of Wi-Fi, that's a new thing too that is coming out even for the carriers. The carriers now are creating their own SSIDs, and putting them on Wi-Fi systems, including Wi-Fi systems like Spectrum. And so your phone will see the SSID for the carrier that you're paying, and it will actually connect without telling you, it will connect to the Wi-Fi system automatically. And so all your data transfer will be through the Wi-Fi system instead of through the 4G system or the 5G system.
Nice.
So that has been a positive benefit. Verizon, especially at these big venues like stadiums, they've gotten that SSID onto those systems, and they've been able to push traffic to the Wi-Fi system and boost their overall data rates and transfers and capabilities when the stadium is full.
Being though you're kind of embedded with the carriers with how they transmit, is this thing that was mentioned a few minutes ago about the airplane issue, did I hear that the carriers have put this on hold right now? And does that mean, if so, does that mean they've turned off the 5G temporarily in all locations or air locations near airports, or do you have any clue about that?
Our understanding is that they're only halting construction around airports,
Okay.
and that they're turning off existing 5G around airports. But as far as everything else, if it's more than maybe half a mile away from an airport, they'll leave it on. So we do. In fact, Asha was just out in October doing 5G testing for AT&T in Georgia. And a company that we were contracting for a time, they picked up a 6-year contract to do 5G testing all around the nation, basically in just about every state. So 5G UE testing. So not using that PC tel scanner pack, but just using actual 5G phones for throughput testing. So yeah, the carriers are still going with 5G. They're just going to find a workaround with the airports and with the planes in order to bypass the issue, so to speak, in order to quell the fears of the FCC until more testing can be done and they can prove that it's not actually interfering. I mean, it is kind of similar to when you get on a plane and they tell you, all right, we're about to take off, turn your phones off, put them to airplane mode. It's not really affecting their system that much to have your phone on, but there are certain wave bands, wavelengths, the higher ones, the lower ones that can interfere with certain things the airplanes are doing, but it's not transmitting on the same bands, so it shouldn't be an issue. But they still, make us do it anyways.
Oh, don't take a chance. So what again was the frequency for 5G?
28 and 39 gigahertz.
Because the radio altimeters are on 4.2 to 4.4 gigs. I thought the 5G they said was right next to it. No?
I will say that's not my understanding.
Interesting.
Unless now I will have to caveat and say our experience with 5G has been with Verizon. And so the 28 and 39 is what Verizon is using. My understanding was that was what the other carriers were using as well. So if there is potentially a 5G system, because I am told by some design engineers that this whole 5G thing is far more complicated than anyone realizes, it may be possible at 4.5 gigahertz, but then the C band is around 6 gigahertz, and 5G can use the C band. So that might be where they're getting the interference idea from.
Gotcha.
So, but again, it's because of this complication. We've got the ultra wideband and the nationwide wideband and the just general 5G on all the various 4G spectrum. It, depending on how the carrier has set up the system nearby, it could be causing a problem. It could be reaching that. Do we have any other questions?
I have a
Okay.
quick question, if you don't mind.
Sure.
It's Christine with WESH. So I haven't had a lot of time in digging into this, but what kind of, you know, and earlier there was a question about, you know, 5G and airports. What about interference with our weather radars? Is there anything that you're seeing from that? Because it's also 5G, we're licensed, but we do see a lot of interference in our radar.
You happen, because that's the first I've heard of it, to be honest. I've not heard of it interfering with the weather radars. So I guess in a sense that could make sense.
Yeah, because it's in the same band.
Mhm. Right, and because it doesn't have the millimeter wavelength does not have a lot of reflection or refraction. Usually once it hits something, it dissolves. It goes back to its electron form, basically. So I'll have to look into that one.
Yeah, you know, because, you know, over the years, in the last couple of years, I'm sure if anyone else is on this call that has radar, it's been an issue. First saw it with, you know, wireless point-to-point connections. And you try to hunt down the farmer that might have it between his buildings, that's causing you issues. But this is just you know, in my mind, how is this going to impact, you know, us for a radar?
Right. Well, certainly if it is impacting, the more 5G nodes that get put around neighborhoods, the more difficulty you're going to have. We kind of think that 5G overall will be a little bit like Windows ME or Windows 8. It'll end up getting glossed over by 6G technology, but at the same time, it will last for a while because they've already spent the money. Carriers have already spent the money putting this equipment and technology out everywhere. So yes, it will end up blanketing. And at that point, someone will have to create some software to deal with it.
Right. And I'm not sure if you touched on this earlier, because beginning of the presentation, I got interrupted a couple times. Sorry. That's what happens when you do these at work on a lunch break. Carriers are sending out notices that you've got to change your phones, they're not going to work. How is that being handled? Because we just got one that was sent to the station. Hey, you know, as of February 22nd, we don't happen to be using AT&T, but it's every carrier. So how backwards compatible are they making their phones? You know, I see this as another way for them to, you know, get everybody to buy new phones, right? And like you're saying, there is no, you know, the consumer is not going to realize or is not being informed that it's a line of sight.
Right. And when it comes to these new phones, the main issue is software updating. It is not it's not a hardware issue, it's a software issue. I used to get this from the carriers as well. They would tell me, you know, oh, the reason your phone's not working is because it's old. And I just look at these people and say, but just yesterday, I literally tested throughput at the Amway Center with an S5, a 10-year-old phone. And I was testing throughput on that DAS system and everything worked just fine. So why is my 1 and a half year old phone not working right? And a lot of it just has to do with software. The older the phone gets, it can't handle the newer software. The newer software package size is too big for the phone's hardware to handle. You know, it takes up too much hard drive space, takes up too much RAM, so the phones can't handle it. That's usually the main issue. If you have a phone that's 2 years old, you should still be able to use that phone for the next 5 or 6 years easily enough. And I was saying at one point earlier, the repairs of systems that we go out and do here around Florida, we are still operating on systems that are Ethernet based. So there is a Cat5 cable going from the head end out to what amounts to a Wi-Fi, or not Wi-Fi, a router at a node, which then from there goes to individual remotes. So, and this is 15-year-old technology, and it's still out there and it's still being used. So the older, as your phone ages, it doesn't necessarily mean it won't work with the new stuff, because they are still making things generally backwards compatible. And you can still find even the Edge network, the 3G network, out on towers broadcasting. One of the engineers at Verizon actually had said to me at one point that, I think it was either Verizon or T-Mobile, one of them actually said to me, was commenting about this very fact, and said that the carriers, if they have an area where there's a high volume of people still using like a 3G or an older model 4G, they will leave that technology up so that those people can still make phone calls, still do something with their phone. But over time, they slowly dwindle that technology down, and they upgrade their local systems. So again, it doesn't necessarily mean that your phone won't work. It's more the hardware of your phone won't work. It's more the software of your phone. If you can't upgrade your Apple software or your Android software, then it may not be compatible with the carriers. And something carriers do that they don't want us to know about, but a great deal of research has been done by consumers in the US, because this is a US problem. You're all familiar with band locking a phone. Or not band locking, carrier locking a phone. You know, you buy a phone from a carrier, it's locked to that carrier. After you've paid it off for a few years, you can get them to unlock the phone so you can use it with other carriers. Carriers download software onto your phone without you knowing that they've done it, but you've given them permission already because when you signed up for their service.
Yep.
Yeah, it's the fine print. They download software onto your phone that allows them to restrict and alter your capabilities with your phone. So even though your phone may be unlocked and you take it from say AT&T over to Verizon, Verizon knows that your phone, when it starts up, shows an AT&T logo. The Verizon knows when your phone starts up that it was an AT&T phone before it was a Verizon phone, and they certainly want you to upgrade your phone to the latest greatest. So they will do certain things that will make your phone look as though it doesn't operate correctly. And then you call in and you say, hey, my phone's not working. And they say, oh, that's because your phone is too old. Even if you literally bought a phone 6 months, 6 months prior, brand new state-of-the-art phone, and you switched carrier 6 months later, they will tell you, oh, sorry, the phone's too old, or the phone doesn't work on our system. You need a new one. But that's the idea. The idea is the carriers are controlling what your phone is doing. And the carriers will not admit to it. All of the Verizon people we worked with, every single one of them, oh, no, Verizon doesn't do that. Verizon doesn't do that. And we kind of proved Verizon did that. I forget who it was we were with, but we kind of proved Verizon does the same thing. We love Verizon. They have the best service in America. We are not Verizon customers though. But the carriers are doing things like that to make your phone look like it doesn't work. I don't want us to casually say ignore such a notice. With 5G, a 4G phone will not work with 5G. You do have to get a new 5G phone because the antenna is different.
Right.
And that's pretty much the only reason. It requires a specific antenna.
Okay. Yeah, because I figured if they would be making a bigger deal out of it with their customers if it really was truly not going to work.
Right.
They don't want to lose the customers, and every customer is not going to upgrade their phone. So they're pretty low key with those notices. Yeah.
That's true. And we have run across some people. I definitely run across a few people that they bought a non 5G, but the latest greatest 4G phone. And then 5G comes out and they get the notice, well, we now have 5G in your area. And they'll come to me, Kenny, I have this brand new phone and 5G was just added to our area. Am I going to get 5G now? Why is my phone not showing that I have 5G? And I look at their phone, I say, it's because you don't have a 5G phone. If you want 5G, you have to go get one. For Asha and I, we have determined that 5G phones, it's not worth it because of those limitations. You know, kind of again, if we were about to get on a plane or go on a road trip or something, or even when that time comes where we had a 5G node right around the corner from our house, and say we wanted to have family movie night, we could step out of the house, point the phone at the 5G antenna, download a movie in a second, and then we can come back inside and watch the movie. But apart from that, the amount of data it downloads is so vast, you cannot physically process the amount of data you're getting in the time you get it. So we, the users, are now the limitation of the technology. 10 years ago, 20 years ago, the technology was slow. We all remember dial-up modems for the internet. So 20 years ago, the technology was the limitation. We could process data faster than it could deliver it to us. Now, we cannot process the data fast enough as it's being delivered. And the industry, though, does not seem to have recognized that change in the dynamic. And they're still trying to push, get it faster, bigger, faster, bigger, faster. Most phones, the picture quality is around 4 to 8 megapixels, or an image will be about 4 megabytes in size. Some are getting up to 8 megabits in size. Well, at 3 gigabytes per second, an 8 megabit file is transferring in nanoseconds. But even on the current 4G system, at a super slow speed of 20 megabits per second, you're still uploading or downloading an 8 megabit pixel in less than a second. So again, the current technology, even at 4G, which is they're trying to replace, is still far out exceeding our ability to process data. So I don't know when the carriers will really realize that and change their dynamic or change what they're doing, but they're always looking for new ways to make money, and 5G is the current new way to make money.
Thank you.
Mm-hmm.
Okay,
Server back over 5G to have to use server.
well,
Asha was just making a point about something that may be useful for the TV industry. When you need to back up a massive amount of data, a 5G system would be very useful if you needed to back up a server, because you could back up huge amounts of data in seconds.
Right. It's more of the background things, not us humans using it. It's our hardware using it, file transfers, etc.
Mm-hmm.
Yeah, moving video files from one location to another.
Right. And you know, the ISPs are the ones that I think really need to catch up the most with fiber connections. You know, I see the advertisements for AT&T fiber at your home, but there's always a disclaimer at the bottom that says you need to have, buy it from us, we'll sell it to you. But there's a disclaimer at the bottom that says you won't get those speeds unless we've already installed the fiber in your neighborhood. So when the ISPs, I think, when they catch up with having fiber in our homes, then even 5G won't make much sense to people as a cellular. You know, we will connect our computers to a router that will connect to the ISP fiber system, and we'll get 10 gigabits per second of data. You know, we'll be way up there in capability.
okay, well, a lot of stuff out there.
Mm-hmm.
Buyer beware.
Yeah,
Yes.
yeah, and yeah, consumer and professional implications there.
Yes.
All right, well, thank you very much,
Thank you
guys,
so much for having us. We appreciate it.
for the info. Some good stuff there. So hopefully everybody at least enjoyed it. If you didn't get good information out of it, which there was plenty. With that, I guess we'll call it a day. Call it a meeting for another month there.
Thanks, Jeff. Thanks, Kenneth.
Thank you.
Thanks, everybody.
See you, everybody.
Thanks for having us again. Have a great day, everyone.
You too.
Thank you.